Dear all, my name is Saverio Pasqualoni and today I will present to you PICO Performance Insight for Collective Operation. PICO will be presented fully at ISC 26 and PICO just won the Meuer Best Paper Award. Why another benchmarking framework? Well, first of all, when one thinks about collective benchmarking, thinks only about the total measure runtime of a collective operation. But if one knows a little bit more, collectives are divided into algorithmic phases, and those algorithmic phases, for example, in the case of this reduce, annual gather, and a reduce scatter phase, can be further divided into rounds, and those rounds can be again further divided into steps, such as a reduce step or a communication step. What state-of-the-art usually report is this total runtime, while with Pico we're interested in understanding when the bottleneck of the system lies, so we're interested in understanding more about those phases and those steps. So we designed Pico with four goals in mind. First of all, we wanted to have fine-grained attribution to reveal which algorithmic step represents a real bottleneck. Then we wanted to have a portable experiment control to compare different MPI and nickel version libraries across different systems. We wanted to have controlled algorithmic baseline to isolate algorithmic differences from backend differences, and we wanted those data to be reproducible, and so we ensured a lot of metadata capture. So we capture version, transport build, environment, variables, nodes, and rank mapping. Now let's say that we want to understand how much of this collective is spent in communication and how much in reduction or data movement to and from temporary buffer. So we instrument it with libpico, and what we get is this graph. We can see that at the beginning we have a very latency dominated scenario in which communication is the overall majority of the collective runtime. Then, when we move in middle-sized vector, we can see that a lot of intranode bottlenecks start to appear, mainly reduction and data movement to and from temporary buffer. Then, when we move to bigger vectors, we can see that communication starts becoming again a predominant factor, but the intranode bottleneck seen before starts becoming again very important. Thank you all for listening, and if you want to check more results for yourself and learn more about Pico, you can check the paper, or if you want to use Pico, there is the link to the source code on GitHub. Pico is free and open source, so we will be very glad if you find Pico useful. Thank you all for listening and see you all at ISC 26.